Short number 2, the size of the hydrogen atom. The hydrogen atom is formed by an electron and a proton. The electron is a quantum particle, therefore, there are two waves associated to it. In the short number 1, we discuss the following. The simplest possible model of a hydrogen atom is called in quantum mechanics the one-dimensional infinite well. The kinetic energy of the electron in the one-dimensional infinite well is positive if it is in the wave with total energy equal to E8 plus mc2. The kinetic energy of the electron in a particular wave increases if the width of the well decreases. In contrast, due to the electrostatic attraction between the electron and the proton, the potential energy of the electron and the hydrogen atom is negative. The absolute value of the potential energy of the electron and the hydrogen atom increases when the spatial localization of the wave associated to the electron increases. Discounting mc2, which is the energy associated with the mass of the electron, the total energy of the electron is the sum of its kinetic and potential energies. The kinetic energy is positive, but the potential energy is negative. If the size of the hydrogen atom decreases, then both its kinetic energy and the absolute value of its potential energy increases. The opposite behavior of the kinetic and potential energies determines the existence of a size of the wave where the total energy of the electron is minimum. This can be considered a crude estimate of the size of a hydrogen atom. Using the exact value of the kinetic energy calculated by solving a Schrödinger-like PPGP equation for the one-dimensional infinite well, we obtain the size of the hydrogen atom is approximately equal to the Bohr radius. This is a really small value, but definitely the hydrogen atom is not a mathematical point with null size. These topics are covered in a recently published book titled Relativistic and Non-Relativistic Quantum Mechanics, both at once. This book was published in September 2023 by Springer Nature, in the undergraduate lecture Notes in Physics book series. The book was written by Professor Luis Breve de Peralta and his collaborators from the Department of Physics and Astronomy at Texas Tech University, Lubbock, Texas, USA. This book is based on the use of the Poveda-Poiet-Grave de Peralta (PPGP) equations. In addition, the authors used the PPGP equations for illuminating discussions about the following topics: the frontiers between the classical and quantum worlds, how the interplay between quantum mechanics and relativity determines the existence of black holes, the observed asymmetry between matter and antimatter. A Spanish translation of this book is also available in BookBaby.